Okay, so for anyone who struggled with the actual new stuff, let me go step by step and show you how to do it again. Alright, so we're going to go back. We did this one in class, but I'm going to do it again. My segment is MN. So the endpoints are negative 5, 4, and 1, negative 2. So if I graph that, there's my graph paper. So there's M and there's N. So if it's a perpendicular bisector that I'm looking for, it must go something like this. It must go this direction because it must be perpendicular to the line, and it must bisect, which means it must cut it in 2 equal pieces. So it's the line that goes directly through the midpoint of MN and is also perpendicular to MN. Now the directions on this paper say to find it in point slope form, but we're going to find it in slope intercept form. So what I'm looking for, so there's my point, I'm doing number 9. I'm looking for the perpendicular bisector to MN. Well, if it's perpendicular to MN, that tells me something about the slopes. It means if I can find the slope of this one, then I'll know what the slope is of the perpendicular bisector because I know something about slopes if lines are perpendicular. So let's find the slope of this one first. So I used the same slope formula that I gave you on the other video, which is y2 minus y1 over x2 minus x1. So now I plug in. Equals. So I have negative 2 minus 4 over, I did this one first, I did negative 2 minus 4, so I got to do 1 minus negative 5. So negative 2 minus 4, that's negative 6. A minus minus means plus. 1 plus 5 is positive 6. Negative 6 divided by 6 is negative 1. Okay, so my slope of MN is negative 1. Remember, what I'm trying to find is the equation of the perpendicular bisector. So this is the slope of the segment that I already have, MN. What I want is the slope of the perpendicular line, because again, I'm looking for the equation of the perpendicular bisector. Well, if it helps you, if you get a whole number for your slope, put a 1 underneath it. Again, if you're good with slopes, don't worry about doing them. But some of you guys struggle when the slope is a whole number. So if I want the slope of a perpendicular line, the rule is all you do is flip the fraction. You flip your numerator and your denominator, and you change the sign. So if this slope was negative, which it is, the slope of the perpendicular, you change the sign. So I'll call this M for slope. So I'm going to my M prime, the slope of my perpendicular. It was negative. Remember, perpendicular slopes, you flip the fraction and you change the sign. So if this slope is negative, my perpendicular slope must be positive. So my slope of the perpendicular must be a positive 1. Another way to think about slopes that are perpendicular is you should be able to multiply them together and it should always equal negative 1. Well, what's negative 1 times positive 1? That does equal to negative 1. Side note, this is not part of this problem, coming off to the side. Because again, some of us are struggling there too. So let's say that I found the slope of my segment, and let's say it was 4 over 9. And let's say I wanted the slope of a perpendicular line to this one. So again, you flip your fraction, so it becomes 9 over 4. And this was positive, so you make it negative. So if this was M, then my M prime would be negative 9 over 4. Okay, so that's just another example. Okay, back to my problem. Okay, so I know my slope. Again, I'm trying to make it look like this. Y equals mx plus b. Because despite the directions up here, I'm going to do it in slope-intercept form. So I want it to look like this. Well, I know the m. I know what this is already because I just found it. It's 1. What I need is the b, the y-intercept. To do that and to use this formula, what I want is I want a point that I know my line must pass through. I need one point that I know my line has to go through. And because I'm looking for a perpendicular bisector, if I was looking for an altitude, if I was looking for a median, I would be doing something else, looking for another point. But because I'm looking for a bisector, that bisector must go through the midpoint of MN. So that's what I'm going to find. Let's find the midpoint of MN using the midpoint formula, which says you add up your two x's. So I have -5 plus 1. I add up my two x's, -5 and 1, and divide by 2. And then I add up my two y's, 4, -2, and divide by 2. -5 plus 1 is -4. -4 divided by 2 is -2. 4 minus 2 is 2. 2 divided by 2 is 1. Okay, this is important. This is an important part of the problem. This is a point that I know my line goes through. Remember, this is x and this is y. So now if I go back to this formula, this y equals mx plus b, I now have an x that I can use and I have a y that I can use because I know my line goes through this point because this is the midpoint of MN. Okay, so I'm going to go back to y equals mx plus b. So what y can I plug in here? What's a y that I know my line goes through? It's 1. So I can put 1 in for x. Okay, what can I put in for m? Well, I know what that is already. I figured it out. My slope is 1. So I could put 1 in for the slope. Okay, what can I put in for x? What's an x that I know my line goes through? -2. The only thing I don't know in that equation is b. So now let's solve for b. 1 times -2 is -2. Add 2 to both sides, and I get 3 is equal to b. So my equation in y equals mx plus b form with a slope of 1 and a y-intercept of 3 is y equals x plus 3. That is my answer of the equation of the line in slope-intercept form of the perpendicular bisector.